So here on number 3, the numerator is in standard form. It's not factored. So I need to go ahead and factor that. So again, if you know how to factor by looking at it, hopefully you can here. That one is x plus 3 times x minus 2. So yeah, there's the factored form. If you don't know how to factor it by sight, you could do the a times c method there. So I'm going to start looking for any holes. Do I have anything that cancels? I don't. None. So everything that's left in the numerator is an x-intercept. So I have x-intercepts at -3 and at 2. The vertical asymptotes would be at x equals -1. That's where the denominator goes to 0. And then notice that this is the first time we've had any multiplicity with one of the factors. It has a multiplicity of 2. So because that is an even multiplicity, then I have togetherness. That's the t in the radii, or one of the t's. So I have togetherness at this asymptote. Okay, next thing I'm looking for is the y-intercept. So you could think about, I would distribute the denominator out. So the denominator would be x plus 1 times x plus 1. So the constant term would come from multiplying 1 by 1, which is 1. So the denominator is 1. And then the constant in the numerator is -6. So my y-intercept is at 0, -6. Okay, and then now I'm looking at the multiplicity. Not the multiplicity, sorry. I'm looking at the power of the numerator and denominator. And because they are equal, they are both degree 2, I have a horizontal asymptote at y equals the ratio of the leading coefficients. So that would be a 1 in the numerator and a 1 in the denominator, which gives 1 overall. So I've got y equals 1. And now then I want to know, does it cross the horizontal asymptote? And so the way we can test that is plug in 1 for y. So this would be 1 equals x squared plus x minus 6 over, and if I distribute the denominator, that's x squared plus 2x plus 1. Put that over 1, I cross multiply, so x squared plus x minus 6 equals x squared plus 2x plus 1. And I know this is kind of cramped on here. I'm going to try my best. So get all your x's on the same side. So if I subtracted by x squared, these would both cancel. But now if I subtracted by x, only this one cancels, and the other one doesn't. So I'm left with -6 equals 2x minus 1x is just x plus 1. And now get x by itself. So subtract 1. So that means it crosses the horizontal asymptote when x is -7. So it does cross there. Okay? So that's really all the information that I need in order to graph this. So let's say I have an x-intercept at -3. So there's my x-intercept. Let's do it in red. There's my x-intercept. Also have an x-intercept at 2. So there's an x-intercept. I have a vertical asymptote at x equals -1. Which is here. I have a horizontal asymptote at y equals 1. Which is there. The y-intercept is at -6. Which would be down here. And I also know it crosses the horizontal asymptote at -7. So if this is -3, -4, -5, -6, -7, it crosses the horizontal asymptote somewhere out here when x is -7. So it has to go through that point. So this is enough information to graph this curve. So like on the right side, we have to go through these points. So it's going to look something like this. right? And it doesn't cross the horizontal asymptote over here, so it's always going to stay beneath it. On the other side of the vertical asymptote, again, it has to be down here and go through, which again makes sense because I'm supposed to have togetherness at the vertical asymptote. And so they both go in the same direction, which is shown here, right? I'm going through that x-intercept, and now that it actually crosses the horizontal asymptote here, and then it's going to come back and stay just above it for forever. So even though it crosses the horizontal asymptote, it still tends towards it at its extreme values. So we've got to come back towards that line, y equals 1. Okay, here is number 4. So first thing I'm looking for, it's already in factored form. So are there any holes? There are not. So next, the x-intercepts. That's where the factors in the numerator go to 0. So I have 2 of them. 2x equals 0, and x minus 1 equals 0. So a lot of times people forget this 2x being out here. I need to go ahead and set it equal to 0 as well. So if I solve that for x, I get an x-intercept at 0, 0. And then the other one, if I solve it, I get an x-intercept at 1, 0. But now this one happens twice. It has a multiplicity of 2, which means at 1, 0, the graph is going to bounce off of that x-intercept. It's not going to actually cross there. Next, find the vertical asymptote. There's only one of them this time. It's where the denominator goes to 0. X equals -1. It has a multiplicity of 3. So I do not expect there to be togetherness, because only when there's an even multiplicity do I expect togetherness at the vertical asymptote. So I don't think that's going to happen here. Next, look for the y-intercept. So this is one of the rare cases. If you think about distributing in the numerator, 2x times x minus 1 times x minus 1. Because there's a 2x out front, right? If I distributed the 2 parentheses first, that's x squared minus 1x, which combines to be -2x, and then -1 times -1 is +1. But now what happens when I distribute here? Where's my constant term? I don't have one, right? I have 2x to the third minus 4x squared plus 2x. So my constant term is gone. It doesn't exist. So that means it's at 0. Which again, if you think about it, makes sense, because if x-intercept at 0 exists, then the y-intercept must also be at 0, 0 when I go through the origin. That's both the x and y-intercept. Okay, so I'm good there. Next, I'm checking the degree. So the degree of the numerator is 3, right? You can kind of see why in this form. If I distribute it again, I would have a 2x cubed as my leading term. And then the denominator is also a degree of 3. So because they have the same degree, I have a horizontal asymptote at y equals a ratio of the leading coefficients. So this time that is 2 over 1, which simplifies to be y equals 2. So I've got that done as my horizontal asymptote. And then lastly, does it cross this horizontal asymptote? So I set y equal to 2 in my equation, and I'm going to solve it. So this is already, the numerator is distributed right here, right? I just needed one more step. So that's 2x cubed minus 4x squared plus 2x over, and then if I distribute the denominator, that's 1, 3, 3, 1. Think about the Pascal's triangle. So that's 1, 3, 3, and 1. And again, you could just distribute that out if you didn't remember the triangle, but I remember the triangle. So I'm going to do it like this. I'm going to cross multiply. And so that's going to give me 1 times the numerator. It's just the numerator. 2x cubed minus 4x squared plus 2x. I want to know where that equals. Now, the denominator all has to get multiplied by 2. So that's 2x cubed plus 6x squared plus 6x plus 2. And now then, get all the x's to one side. So 2x cubed and 2x cubed cancels. If I move this over and add it, I'm going to have a 10x squared here. So if I move the 2x over and subtract it, so 6x minus 2x is 4x. Plus 2, I can bring it down. Set it equal to 0. So there's actually 2 times that this might cross. So because it's a quadratic, I could either factor or I could use the quadratic formula. This one is not going to factor. So I'm going to use the quadratic formula here. So that's going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, look at this, the determinant. Negative 4 times 10 is negative 40. Negative 40 times 2 is negative 80. 16 minus 80 is negative 64. So because I have a negative number underneath my radical, that's going to give me complex roots. So because they're complex roots, it's not really going to cross this horizontal asymptote. So the answer, does it cross? No, it doesn't. That was a lot of work for it not to cross. Anyways, let's put all this information down that I have on the graph. So I have an x-intercept at 0, 0. I have an x-intercept at 1, 0. It's going to bounce. I have a vertical asymptote at x equals negative 1. I'm going to put a dotted line at x equals negative 1. I have a horizontal asymptote at y equals 2. And it never crosses there. Sorry, y-intercept is also 0. So this could be a little confusing, but if you think about, let's just think about it on the right side over here. As we approach the vertical asymptote, we've got 2 options. It could either go up, like that at the vertical asymptote, or it could go down. So which one does it do? Well, if it went up, it would cross the horizontal asymptote somewhere, which I just found it never gets crossed. So that means it can't go up. It has to go down here. So if it's going down there, I know we cross at 0. And then at an x-intercept of 1, we found that it bounces there because it has an even multiplicity. So it's going to bounce back up, and then it's going to stay just beneath that horizontal asymptote forever, right? Because it never crosses it. Now then, on the right side, we've got 2 options. It could be like this, right where it goes down, or it could be above it like that. Well, if it was beneath it, if it was beneath the horizontal asymptote, what would exist? There would be another x-intercept. It would have to cross the x-axis somewhere right here. But I know it doesn't. Therefore, it must always stay above, like that. So this would be what that graph would look like. One more thing I want to add is, notice at the vertical asymptote how there's not togetherness, which makes sense because I had an odd multiplicity. So that's another thing to check off the list. Yeah, it's fitting like I think it should. Number 5 is already in factored form for me. So I start by looking, are there any common factors? There are not. That means there are no holes, which means the factors in the numerator give the x-intercepts. So there's an x-intercept at 1, 0, and it's going to bounce because it has a multiplicity of 2. And then I can look at the horizontal asymptote. Let's look at the vertical asymptote next. which is the factor in the denominator. So it's at x equals -5. And it's going to have togetherness there. Because it's a degree 2 factor as well. All right, the next thing we could look for is the y-intercept. So I think the y-intercept is easier to find when it's in standard form. So I'm going to distribute. So the numerator, that would be -3 times x squared minus x is -2x, and then plus 1. And then I need to distribute again. So that's going to be -3x squared plus 6x minus 3 in the numerator. And then in the denominator, if I distribute that, that is x squared plus 5x is plus 10x. And then 5 times 5 is 25. So the y-intercept is going to be at the ratio of the constants. So that's -3 over positive 25. Okay. And then next, check the degree of the numerator and the degree of the denominator. Well, they both are degree 2. So when they have equal degree, I have a horizontal asymptote at y equals a ratio of the leading coefficients. So this time that would be -3 over 1, which is y equals -3, is my horizontal asymptote. And then the last thing I have to check is, does it cross this horizontal asymptote? Because sometimes it can. And so I'm going to plug in -3 for y equals, and I'm going to use the standard form, -3x squared plus 6x minus 3 over x squared plus 10x plus 25 over 1. And so now then if we cross multiply, 1 times the numerator is just the numerator. So it's going to leave me with -3x squared plus 6x minus 3 equals -3 times x squared is -3x squared. -3 times 10x is -30x. -3 times 25 is -75. Get all my x's on the same side. So the -3x squareds are going to cancel. If I add 30x to both sides, that's going to give me 36x equals, now if I add 3 to get rid of that over here, it's going to be -72. Divide by 36. I find I have a hole at x equals -2. Or not a hole, sorry. I find that it crosses the horizontal axis at -2. So, does it cross? Yes, at -2. Okay, so I'm going to take all this information and try to graph it. So I have an x-intercept at 1, 0. It's going to bounce. I have a y-intercept at -3 25ths. That's just going to be somewhere right here. I know I have a horizontal asymptote at y equals -3. Somewhere here. I have a vertical asymptote at x equals -5. I'm going to draw that right here. And I know we cross the horizontal asymptote at -2. So somewhere right here it has to cross. So again, we can kind of see what the graph's going to look like. So let's focus on the right side of the vertical asymptote first, because that's where I have the points already here for me. So at the vertical asymptote, it could either start down here, cross, go through the y-intercept, then it has to hit this x-intercept and bounce, right? So it comes back down. And now then I know it's going to get closer to that horizontal asymptote, but it's going to stay above it forever. Like that. Right, that's one option. Or the other option is it could be up here, Okay, but if it did that and it had to, think about it, if it had to get a y-intercept here, then it would have to have another x-intercept. Does everyone follow that? And I know this x-intercept doesn't exist, so this red piece has to be wrong. It can't do that. So it has to be this blue one that I drew. And again, it kind of makes sense. It crosses this horizontal asymptote at the one place that I thought it should. Right here. And now because there's togetherness at the vertical asymptote, then I know on the other side, it must also be going to negative infinity as it approaches it. But now then think about it. As I come up to the horizontal asymptote, does it ever cross it again? It can't. It only crosses it at -2. So it's going to stay beneath the horizontal asymptote over here. And so this is a general form for what the graph would look like. Okay, so we are at 6. This is in standard form. It's not in factored form. So first thing I want to do is factor it. The numerator kind of already is factored. The denominator is the difference of perfect squares. So that's x plus 2 times x minus 2. So now I'm looking, do I have any common factors? I don't. That means there aren't any holes. So the x-intercepts would happen when the numerator goes to 0. So if I solve that, x equals 9. X-intercept is at 9, 0. Okay, this time I have 2 vertical asymptotes. I have a vertical asymptote at x equals -2, and I have one at x equals +2. Neither one of them has togetherness, though, because they each are happening to the first degree. Next, let's check for the y-intercept. So I'm going to use standard form. It's going to be a ratio of the constants. So that's 9 over -4, which is -2.25 is the y-intercept. And lastly, horizontal asymptote. So if I look at the degree of the numerator, it's 1. The degree of the denominator is 2. So because the degree of the numerator is less than the degree of the denominator, I have a horizontal asymptote at y equals 0. It's just one of our rules. And now then I want to check, does it cross this horizontal asymptote? So I could say y equal to 0. So 0 equals 9 minus x over x squared minus 4. And then we solve it. Put it over 1. Cross multiply. So this says 9 minus x equals 0. So at x equals 9, we cross the horizontal asymptote. Which again makes sense if you put it all together, because the horizontal asymptote this time is the x-axis. And do we ever cross the x-axis? Yes, at 9. That's the x-intercept. So again, it's all kind of fitting together, so it makes sense. So let's graph this. I have an x-intercept at 9. So I'm going to put that way over here. I have vertical asymptotes at x equals 2. And x equals -2. I have my horizontal asymptote at y equals 0, which is the x-axis. It can only get crossed one time. Okay, and then I graph the x-intercept. I've graphed the vertical asymptotes. The y-intercept is at -2.25. So that means it has to cross here somewhere. Okay, so this is the first graph we've had that has 3 pieces, because there is a piece on the left of this asymptote, there's a piece between the 2 vertical asymptotes, and there's a piece on the right of that vertical asymptote. The only piece that I feel good about knowing where it's at is here in the middle, right? Because I know it can't cross the horizontal asymptote in the middle, and I know it has to tend towards the vertical asymptotes, so it must do something like this and then turn back down as a parabola, like that in the middle. That's the one piece I feel good about. Now, to find the other pieces, it's a little trickier. So what I'm going to do is, I have guesses. Actually, I think I might could guess it without plugging in values. So let me tell you why I think I can guess it. This is the new thing I learned about togetherness. So because there is no togetherness at these vertical asymptotes, I'm just going to draw this in highlighter. My guess is this piece must be up here in yellow, and this piece must also be up here, because that would not give me any togetherness at the asymptotes. And then here, this piece would actually cross the x-axis there and then stay just beneath the horizontal asymptote forever. That's just my guess. I don't know that for sure. Again, this togetherness business is new to me. So the way that I would have done this before is I would have plugged in values to figure out where it should happen. So like over here on the left piece, I can pick any x value that's less than -2 and see what the y value should be. If the y value is positive, it's happening up here. If the y value is negative, it's happening down here. And I can draw the graph from there. So let's plug in -3. So if I did, that would be 9 minus -3 over -3 squared minus 4. So if I think about it, the numerator is 12. The denominator would be 9 minus 4, which is 5. So that's 2.4. So when x is -3, the y value should be 2.4, which is positive, which again fits with where I had traced that graph. Pretty cool. Thank you, togetherness. And I'm going to do the same thing on the right side. So if I plugged in a +3, so that would be 9 minus 3 over 3 squared minus 4. So that would be 6 over 5, which is 1.2. So when x is 3, the y value should be 1.2, which is also positive, which means I'm right on the money with that togetherness. That togetherness is going to be a game changer for me. It's going to make my life easier. So here I have to cross, and then I have to tend back towards the horizontal asymptote forever. So it'll stay just beneath that horizontal asymptote. Because remember, at its extreme values, when x's get really big or x's get really small, it's getting closer and closer to this horizontal asymptote. So I've got to keep the graph around there at its extreme values. Again, here in the middle, it can do some weird stuff. But there's that graph. Okay, looking at this one, it is already in factored form. What I'm noticing here is this won't factor anymore. Multiplies to be 8, but combined is 4. Well, 1 and 8 won't work. 2 and 4 won't work. So that won't factor again. This one actually will factor, though, in the denominator. So if I factor the denominator, it has a GCF of x. That's going to be 4x, then it's out front. And that's going to be an x to the first minus 4 is left there. And so then the numerator was x squared plus 4x plus 8 times x minus 4. So for the first time on this page, I have a common factor in the numerator and the denominator, which means that's going to give a whole. So I have a whole when the x value is 4. Now to find the y value, we actually plug in 4 to everything that didn't cancel out. So if I plug in 4 here, that's going to be 16 plus 16 is 32 plus 8 is 40 over 4 times 4 is 16. So 40 over 16 is 8 16, so that's 2.5. So I'm going to have a hole in my graph at 4, 2.5. Good to know. X-intercepts. So The only thing left in the numerator that could give an x-intercept is this quadratic, but I don't think it's going to because it didn't factor. So I think the only other way we could find them is using the quadratic formula or by graphing it. So I'm just going to use the quadratic formula very quickly with this. That's going to be negative b plus or minus the square root of b squared is 16 minus 4 times a is 1 times c is 8. So again, think about what's underneath the radical. 4 times 8 is 32. 16 minus 32 is negative 16. So because I have a negative number underneath the radical, then it's going to be imaginary roots, which I don't graph, which means there are no x-intercepts. Okay? Vertical asymptote. So because this canceled, that's going to be a hole. So here's going to be the vertical asymptote. So I could set 4x equal to 0, solve it. So x equals 0 is my vertical asymptote. Okay, now then the y-intercept. So again, if you think about this, because there's a vertical asymptote at x equals 0, then it can never cross the y-axis. So I know there's not going to be a y-intercept, but let's just think about what happens. If I plug in 0 for x, look at the denominator. It's going to be 0 times negative 4, which is 0. So you're going to have some number over 0 which does not exist. So that means there is no y-intercept. And so then lastly, I need to check for the horizontal or oblique asymptote. This time, the degree of the numerator is 3. The degree of the denominator is 2. So that means there's going to be a slant or an oblique asymptote. And it's going to happen at, I've got to do the long division. Oh, man. Okay, so let's go ahead and get this in its standard form. So I need to, I'm going to do this work off camera because I don't want to turn it just a complete mess on here. I know what you're thinking. It already is a complete mess. So what I'm doing is I am distributing x squared plus 4x plus 8 times x minus 4 in the numerator. So that's going to give me x cubed minus 4x squared plus 4x squared minus 16x plus 8x minus 32. And then I'm combining my like terms. So I have an x cubed minus 4x squared plus 4x squared cancels. Minus 16x plus 8x is negative 8x. And then minus 32. So the numerator is x cubed minus 8x minus 32. In the denominator, if I distribute that, that's going to be 4x squared minus 16x. So that's easy enough. So now when I do my long division, the numerator goes inside. So I have an x cubed. So the next term I need to write is my x squared term. It doesn't exist, so I write 0x squared. And then I have x to the first is minus 8x, and then the constant is minus 32. And this is being divided by 4x squared minus 16x. So now then I've got a 4x squared. I want it to become x cubed. So 4x squared times what is x cubed? It needs to be 1/4 x. So 1/4 times 4 is 1, and x squared times x is x cubed. Now then 1/4 x times negative 16x, that's going to be negative 4x squared. Now then on long division we subtract, so I change those signs. The first one cancels. If it doesn't, you're doing it wrong. Combine those, that's a 4x squared. Bring down your other terms. So bring down minus 8x. Bring down negative 32. Now I have a 4x squared. I want it to be 4x squared. So 4x squared times what is 4x squared? It's a positive 1. And I'm actually done. Because I can't go to another power. I don't really care what cancels down here. This is my slant asymptote. Y equals 1/4 x plus 1. So slant asymptote at y equals 1/4 x plus 1. Oh, gosh. And now I have to check, does it cross the slant asymptote? Because it can. So I'm going to do this work off screen too. So to check if it crosses the slant asymptote, we would write 1/4 x plus 1 equals, and then I'm going to write the standard form that I just found. So it equals, the numerator is x cubed minus 8x minus 32 over, the denominator is 4x squared minus 16x. So I'm going to put 1/4 x over 1. So when I cross multiply, 1 times the numerator is just the numerator. So x cubed minus 8x minus 32 equals, and now that I've got to distribute 1/4 x plus 1 times 4x squared minus 16x. So 1/4 x times 4x squared is going to give me 1x cubed. 1/4 x times negative 16x is going to give me negative 4x squared. And I'm just remembering something as I'm doing this. 1 times 4x squared is 4x squared. 1 times negative 16x is negative 16x. I think there's something we can do with the remainder that somebody told me about, but we'll see here. So now, here's what my equation looks like. X cubed minus 8x minus 32 equals x cubed minus 4x squared plus 4x squared minus 16. So on the right side, my 4x squareds cancel, and I'm left with x cubed minus 16x. So now get all your x's to the same side. So I'm going to subtract by x cubed, so those cancel. I'm going to add by 8x on both sides. So now I have negative 32 equals negative 8x. Divide by negative 8. So I get x equals 4. So that means it's going to cross the slant asymptote at 4. So my little bit of, my note that I want to write here. Here's my slant asymptote, and I want to write it's crossed at x equals 4. Okay, so here we go. Let's graph it. The problem is this is a lot of work, I feel like, and I feel like we're not going to get a lot out of it. So I'm going to start with a slant asymptote. So the y-intercept is 1, right? We're in slope-intercept form. Y-intercept is 1, and the slope is 1/4. So I could rise 1 and run 4. There's my next one. And here, I'm just looking. I'm actually wrong. Yeah, dang it, Cody. So let me tell you why I'm wrong. Right here it says it crosses it at 4, but right here I found 4 was the whole at 4 2.5. Oh gosh. So what that means is when you do the long division for your slant asymptote, you probably need to do the simplified version. I think that's right. So like where I canceled these out, when I do my long division, I just need to divide these two by each other. The x squared plus 4x plus 8 divided by 4x. So let me just do that very quickly. I think it's the same answer. X squared plus 4x plus 8 divided by 4x. So let's see here. That's going to be 1/4 x plus 1. So yes, it's the same place. The difference is it can't actually cross here. So that means it never crosses. So then my slant asymptote, because I went up 1 and right 4. Let me get back to here. Just ignore the crossed. It doesn't get crossed. Up 1, right 4. I could also go down 1, left 4. Which would be here. So here's my slant asymptote. They're in yellow. I have a vertical asymptote at x equals 0, which is here. I know there's a hole at 4 2.5. So So if I go to 4, right here, the slant asymptote is at 4.2, so 4.2.5 is up here. So that gives me a little bit of an idea for what the graph's going to do there. So because there's a hole here, I know the graph's going to happen up here. It's going to tend towards the asymptotes like that. Okay, and I also know that on the left side of the vertical asymptote, if it tended towards the asymptotes this way, there's two problems with that. Up here, it would have to have another x-intercept, or it'd have to have a x-intercept that doesn't exist. And there would also be togetherness at this vertical asymptote, which I didn't find there to be. So it's not going to be happening up here. It's going to be happening down here. And it's not going to cross the x-axis. Right, so it looks like there's a little piece here where it could cross, but it's not going to. So that means it's going to happen beneath this slant asymptote. It's going to rise, and it's going to start turning down at that vertical asymptote, like so. And so that would be my graph of number 7.